Neptune, the dark spots that appear overnight. We look away, and Neptune is different. A storm where there was none. A dark oval etched into blue clouds. A planetary-scale system forming in silence, 4.5 billion kilometers away. Then we look again, and it's gone. On Neptune, weather does not simply evolve. It appears, it transforms, it disappears. Sometimes in just a few years, sometimes faster than our observation. Cycles can fully capture. Neptune is not static. It changes while we blink. Neptune is an ice giant, smaller than Jupiter and Saturn, but still vast beyond imagination. Beneath its upper cloud layers lies a deep atmosphere rich in hydrogen, helium, and methane. Methane absorbs red light, giving Neptune its striking blue color. But beneath that calm blue appearance lies one of the most extreme weather systems in the solar system. Neptune holds the record for the fastest sustained winds ever measured on a planet. Wind speeds can exceed 2,000 kilometers per hour, faster than the speed of sound on Earth. These winds whip across a planet that receives only a fraction of the sunlight Earth does. Neptune radiates more internal heat than it absorbs from the sun. That internal energy helps drive convection, fueling storms in an atmosphere already primed for instability. The most dramatic features are the dark spots. The first major dark spot was observed in 1989 by Voyager 2, the only spacecraft ever to visit Neptune. It appeared as a massive oval-shaped storm system, similar in size to Earth. It resembled Jupiter's Great Red Spot, except it did not last. When the Hubble Space Telescope observed Neptune a few years later, that storm had vanished. In its place, nothing. Then years later, another dark spot appeared. Different location, different shape, same behavior. Neptune's dark spots are high-pressure vortices, massive storm systems rotating within the upper atmosphere. They are thought to form when atmospheric instabilities intensify within the planet's zonal wind bands. Unlike Jupiter's long-lived Great Red Spot, Neptune's vortices are unstable. They migrate, they shrink, they fade. Sometimes they fragment into bright companion clouds. Sometimes they dissolve entirely. The life cycle of these spots is one of the biggest clues to Neptune's atmospheric behavior. They seem to form at mid-latitudes, drift toward the equator, and then disintegrate. The equatorial region may destabilize them, perhaps due to changes in wind shear or planetary wave interactions. But we are not continuously watching. That is the second clue. Our observations are intermittent. Voyager 2 flew past Neptune in 1989, a brief encounter measured in days. Since then, our primary monitoring tool has been Hubble and ground-based telescopes. We observe Neptune in snapshots, months apart, years apart. A storm can form and evolve between scheduled observation windows. It can intensify, migrate, and begin to dissipate before we capture its full life cycle. We reconstruct its behavior from fragments. Neptune completes one orbit around the Sun every 165 Earth years. Seasons last decades. When Voyager arrived, the southern hemisphere was illuminated. Now the northern hemisphere receives increasing sunlight. Seasonal changes may influence atmospheric circulation, but we have not observed a full Neptune year since modern telescopic monitoring began. We are watching a slow seasonal clock tick, but only through occasional glimpses. The third clue is speed. Neptune's winds are not just fast, they are structurally complex. The planet hosts multiple east-west jet streams that can interact, merge, and destabilize. When instabilities amplify, vortices can spin up rapidly. In fluid dynamics, vortices can form from shear instabilities when adjacent flows move at different speeds. On Neptune, extreme temperature, gradients, and rapid rotation create ideal conditions for such instabilities. A storm can emerge from subtle atmospheric shifts, amplified over time, until it becomes visible even across billions of kilometers. Then conditions change, and the structure collapses. From our perspective, it feels abrupt. In reality, it may be the natural life cycle of a dynamic system we barely observe. What makes Neptune unsettling is not just its storms. It is the gaps. Between observations, the planet continues, Cloud systems move, energy redistributes, vortices form and dissolve. Entire atmospheric events may occur unseen. We imagine the solar system as stable, fixed, predictable, mapped. But Neptune reminds us that planetary weather is alive. It evolves continuously, and we only visit with telescopes. Each image is a snapshot of a process already underway. Each dark spot is a chapter we catch mid-sentence. We look away, and Neptune is different. A storm where there was none. A vortex that did not exist in the previous frame. Then years later, the same region is smooth again. How much do we miss? How many storms have formed and faded without record? Neptune rotates in just 16 hours. Winds race faster than any hurricane on Earth. Energy rises from its interior. Instabilities grow in deep layers we cannot directly see. And our instruments check in occasionally, like distant observers blinking at the edge of the solar system. Neptune changes while we blink, and the real mystery may not be the storms we detect, but the storms we never see.